There are places in the universe where gravity becomes so overwhelming that reality itself breaks down. These are black holes, and they're not just cosmic vacuum cleaners. They're the key to understanding the fundamental nature of space and time. A black hole forms when matter is compressed into such a tiny space that its gravity becomes inescapable. The concept comes directly from Einstein's general theory of relativity, published in 1915. General relativity describes gravity not as a force, but as the curvature of spacetime itself. Mass tells spacetime how to curve. Curved spacetime tells matter how to move. If you compress enough mass into a small enough volume, the curvature becomes so extreme that spacetime folds in on itself. A black hole is born. The boundary of no return is called the event horizon. Once anything crosses this invisible surface, it can never come back, not even light. The size of the event horizon is called the Schwarzschild radius. For Earth, it's about 9 millimeters. Compress our entire planet to the size of a marble, and you'd have a black hole. At the very center of a black hole lies the singularity. This is where our understanding of physics reaches its limit. At the singularity, density becomes infinite. Spacetime curvature becomes infinite. The laws of physics as we know them simply stop working. The idea of dark stars was first proposed in 1783 by John Michell, an English clergyman and natural philosopher. He used Newton's laws to argue that if a star were massive enough, its escape velocity would exceed the speed of light. The star would appear completely dark. In 1916, just months after Einstein published general relativity, Carl Schwarzschild found the first exact solution to the equations. It described what we now call a black hole. Schwarzschild made this discovery while serving on the Russian front during World War I. He died shortly after, never knowing how important his solution would become. For decades, even Einstein himself refused to believe black holes could be real. They seemed too strange, too extreme to exist in nature. The term black hole wasn't even coined until 1967, when John Wheeler used it in a lecture. Before that, they were called frozen stars or collapsed stars. The first real black hole was discovered in 1971. Cygnus X1, an X-ray source in the constellation Cygnus, turned out to be a black hole orbiting a blue supergiant star. Black holes form when very massive stars, at least 20 times the mass of our Sun, run out of nuclear fuel and collapse. The collapse triggers a supernova, one of the most violent events in the universe. The outer layers explode outward while the core implodes into a black hole. Once formed, a black hole never stops growing. It pulls in gas, dust, asteroids, planets, even other stars. Everything that comes too close gets consumed. The accretion disk can shine brighter than entire galaxies. Some of these feeding black holes become quasars, the most luminous objects in the known universe. At the center of nearly every galaxy, including our own Milky Way, lurks a supermassive black hole. Sagittarius A, the black hole at the center of the Milky Way, has a mass of 4.3 million suns. It's been sitting there, quietly, for billions of years. In 2019, the Event Horizon Telescope collaboration gave humanity its first direct image of a black hole, the supermassive black hole at the center of galaxy M87. The image shows a ring of light bent by the black hole's extreme gravity, a phenomenon called gravitational lensing. The dark center is the black hole's shadow. Stephen Hawking made one of the most profound discoveries about black holes. They aren't entirely black. Due to quantum effects near the event horizon, black holes slowly emit radiation and lose mass. Given enough time, trillions of years, a black hole will eventually evaporate completely. Black holes aren't just destructive monsters. They're fundamental to the structure of the cosmos. They shape galaxies. They create the elements. They may even hold the secret to quantum gravity.